Blake Richards. I'm an assistant professor in the Department of Neurology and Neurosurgery and the School of Computer Science at McGill University, as well as a core faculty member and Canada CFAR AI chair at MILA, the Quebec Artificial Intelligence Institute. And I am also one of the researchers who works on the HIBAL project. The person who had the biggest impact on my career in terms of my scientific direction was Geoffrey Hinton. I was lucky enough to be able to take neural networks with him as an undergraduate student at the University of Toronto, and also to do some research projects with him while I was an undergrad there. And his vision, his understanding of the importance of developing workable formal theories for how networks of parallel processing units can achieve complicated computations of the sort that allow us to do the stuff that we do really changed my outlook and changed the direction of my research greatly. I chose this field of study, which for me is the interaction between neuroscience and artificial intelligence, because I really do believe that there are general principles of intelligence that apply equally to both biological and artificial systems. And to me, uncovering these general principles is one of the deepest things that we can do in science nowadays. It's the equivalent of discovering the principles by which, the principles that govern the movement of all physical objects in the world. So we can discover the principles that govern the behavior of all intelligent creatures in the world or in the universe. Really, this is the scientific discipline that grew out of what was called cybernetics in the 1950s. And to some extent, I still view myself as a cybernetician, if that's a word. And I would definitely recommend this field to other people because I think there's just so many fascinating questions that can be answered. The biggest challenge in my career has probably been achieving an appropriate work-life balance. It's taken me a long time to get to the point where I would say that I have achieved that, but I think I largely have now. I think it's really important to have a work-life balance, to be at home with your family, and I feel like I've finally achieved that. Big Brain is ultimately advancing my research because we're, in my lab, looking for ways in which neuroscience data can inspire the development of artificial intelligence systems. And the Big Brain data provides us with a level of resolution regarding human brain architectures that no other data has in the past. And that's very exciting for us and something that really could only happen in the context of an open science initiative like this, where the labs that are collecting this kind of research are actively sharing it with computational labs like mine that don't have access to this kind of data otherwise. Most recently, as a result of these studies with the Big Brain data, we have some interesting findings showing that networks that have some top-down modulation based on architectures from the human brain are potentially better at resolving ambiguous images and understanding ambiguous images. And if that result pans out, I look forward to showing to the world the ways in which information about the human brain can actually inform the design of artificial intelligence systems.